Hello, here we are on mock exam for unit circle and trig graphs. Um, First, I'm going to tell you how to use this data table here. I put the calculator here because I want to show you how this data table works exactly like the calculator does. Okay? So first of all, I'm going to turn on the calculator. I am going to change my calculator to degree mode because my calculator starts out in radian mode. Okay. You should always know how to change your calculator to degree mode to prevent academic disasters. So, first I'm going to do sine of 30. If I do sine of 30 degrees, and I know it's going to do 30 degrees because I just set it to degrees, I get 0.5. Let me check the table. If I do sine of 30 degrees, then I have the intersection of this row and this column, and it's 0.5. Do you see how that works? Okay. So now I'm going to do tangent of 60 degrees. That gives me 1.73. Tangent of 60 degrees gives me, do you see the intersection? 1.73. Okay? I can also do the opposite. I could say 0.5 is the inverse cosine of what angle? Well, since 0.5 is found here in the cosine row and it's in the 60-degree column, inverse cosine of 0.5 is going to be 60 degrees. So let me do that. Inverse cosine of 0.5 is 60 degrees. Okay, so that's how it works. You can use this table as if it was a calculator because in this test, in this mock exam, we only ask you for these following reference angles. And by knowing these reference angles, you can find any other angle which is greater than 90 degrees or negative. You can use the reference angles to find the sine and cosine for those angles. Okay, let's go to number 1. Use the graph below to find the cosine of theta. The shaded angle is theta. Okay, so this angle is theta. Do you see that it gives us the coordinates of this point here? The red point here is at the coordinates negative 8 over 15, comma 15, comma 17. Now, this, of course, is the x coordinate, and this is the y coordinate. And when you're on the unit circle, the x coordinate and the y coordinate have to be a certain combination of numbers in order to actually be on the unit circle. Okay? And it turns out that the left number, the x-coordinate, is actually the same as the cosine of this angle here, and the right number, the y-coordinate, happens to be the sine of this angle here. And I'm just going to show you why that is. Okay? The reason why that is if I draw a triangle here, the way you draw this triangle is you use the hypotenuse between the middle of the circle and the red dot. You draw a vertical line from the red dot to the x-axis, and then you close it into a triangle, okay? And then you can see that the sides of this triangle actually correspond to the coordinates of the red point, right? The x-coordinate, negative 8, comma, divided by 15, is this distance here. Why is it negative? Because it's going to the left, right? Then the height of the red dot is 15, comma, divided by 17, and that's a positive number because it goes up, right? So we can use the coordinates that we see right here to figure out what the distances are on the sides of this right triangle that we just drew. I forgot to draw that it's a right triangle, right? Now, do you know how this angle here is the angle theta? Well, this angle theta creates this right triangle, and we can figure out what the sine and cosine of this angle are, right? So what would be the sine and cosine of this angle? Remember, sine of theta is opposite over hypotenuse, and cosine of theta is equal to adjacent over hypotenuse. Now, what is the length of the hypotenuse here? Well, I'll give you a hint. It's called the unit circle. The unit circle has a radius of 1, so the hypotenuse of this triangle, as with all other right triangles you draw within the unit circle, is 1. So, I am going to write an expression for opposite over hypotenuse. What is the opposite from the angle theta? It is that, length right there. 15 divided by 17 divided by the hypotenuse of 1. So, actually, opposite over hypotenuse is just equal to 15 over 17. And we already said that, didn't we? We said that the y-coordinate of the red dot is going to be the sine value of the angle which corresponds to that red dot. So, the sine of theta, in this case, is positive 15 over 17, right? Equals 15 divided by 17. What would be the cosine of this angle? It would be negative 8 divided by 15, right? What are they asking us for, by the way? Oh, they're asking us for the cosine. So the cosine of this triangle would be 8 divided by 15, okay? All right, now, when we do this one, we won't go through all that explanation because you've already heard it once. You don't need it more than once. The unit circle below is showing the angle theta, and the angle theta has this x and y coordinate for the red dot. Okay. Let's see. What is the sine of theta? Well, remember that the cosine of theta is the x coordinate, and the sine of theta is the y coordinate. And the relationship between cosine and sine and the red dot are that the red dot is formed by this angle here, and the cosine and sine of that angle happen to also be the coordinates of the red dot. Okay? That only works out if you're using a unit circle, which is a circle of radius 1. Okay? So in this case, they want the sine of theta. That means they want the y coordinate. So we're just going to put negative 8 over 25. Okay? All right. That was number 1 and number 2. Let's move on. Number 3. Evaluate the expressions below without the use of a calculator. Use the sine, cosine, tangent table above. Okay. So I just showed you how to use the table. First thing we're going to do, draw the triangle corresponding to this angle in the unit circle and write down the reference angle. Okay. Now, remember, whenever you draw an angle on a unit circle, the 0 point is right here, right? The 0 direction is here. When you start counting degrees, remember that 90 degrees is a right angle. To go all the way around the circle is 360 degrees. So if I say negative 210 degrees, I just need to figure out which way is positive, which way is negative. Remember that positive is in the opposite direction of the clock, okay? So we are going to go in this direction, okay? And the reason why we start here and we go in the direction above is because the first quadrant is the quadrant that we're most familiar with, right? So when you were in, elementary school, when you didn't know negative numbers yet, we used the yellow part of this graph to make number lines just for positive numbers and for counting and practicing subtraction and things like that, right? So we were very familiar with the yellow part of this graph. Then what happened? Then we started working with two variables, x and y. We started graphing things, positive numbers separated by a comma, and one was the horizontal position, the other was the vertical position, right? When we did that, it was in the green part of this graph because the green part of the graph has positive x and positive y. That is the first quadrant, okay? So you start at the number line that you used for, many, many years from elementary school. We used this number line, the positive part of the number line. Then we moved into the green part of the graph because that's where we did our first graphing exercises in like 6th grade. Okay? So that is why the angle is positive in that direction. Okay? So the angle is negative if you go in this direction. The angle is positive if you go in this direction. So negative 210 would be going in this direction. This would be negative 90. This would be negative 180. And then negative 210 is how many degrees past negative 180? Well, the difference between 210 and 180 is 30. So I would go a little bit past there, 30 degrees past there, and then I would draw the angle negative 210 degrees. So like negative 210 degrees is such a big negative angle that it actually comes out of the negative part of the circle and it goes to the positive part of the circle, which is kind of ironic. Okay? So what is the reference angle of this little triangle here that we drew? Remember that whenever you draw a triangle in the unit circle, you draw the red dot, you draw the hypotenuse, and then you draw a vertical line straight down or straight up from the red point to the x-axis. Okay, so the right angle here is here. Okay, so what is this angle here? Well, remember we said to get to negative 210 degrees, we went negative 180 degrees, and then we went 30 degrees past that, right? So that means that this little triangle here has a 30-degree angle at the origin. And if it has a 30-degree angle at the origin relative to the x-axis, that means that is the reference angle. Okay, reference angles are between 0 and 90 degrees. They are the angle that's in the center of the circle, which define the size of the reference triangle that you draw between the x-axis and your angle. Okay, so a reference triangle could be pointing up or it could point down like that. Okay, but basically a reference triangle, even though it might point up or point down, it always has a positive angle between 0 and 90 degrees. Okay, so this reference angle happens to be 30 degrees. Okay, all right, let's do 135. What is the reference, or what is the angle 135? What does that look like? Remember, positive starts from 0 and then it goes up. 135 is slightly more than 90, right? 135 is 45 degrees past 90. Oh, 45 degrees is a special angle. It's like exactly diagonal, right? So here's my 135 degree angle. And there's my red dot, and then I can draw my reference triangle like that, right? The angle, the reference angle for the 135 degree angle is this angle here. What angle is it? Well, let's see. 135 degrees takes me to this red dot, and I am lacking some degrees until I get to the 180 degree mark. I can figure out how much is missing by doing 180 minus 135. By the way, that's 45 degrees. Okay? Okay, so that makes sense. 90, 45, and this would be 45 also. Okay? So guess what? My reference angle for this angle that I drew is 45 degrees. Okay? I wanted to know that too, right? Draw the triangle corresponding to this angle, write down the reference angle. Okay. Finally, let's do 240 degrees. So I'm going to start here at 0. Positive is going this way, and it's a positive angle. I go 90, I go 180, I go 270. Wait a second, it's 240, which is less than 270. In fact, it's 30 less than 270. It would be about like that, right? So the red dot goes here. The vertical line goes from the red dot and meets the x-axis. That makes my reference triangle. My reference angle would be this angle right here. The reference angle is the angle between the x-axis and the hypotenuse. So in this case, the reference angle is, how much would it be? So like 240, so this would be 90, 180, and then what's left over? 60, right? 240 minus 180 is 60. So this angle here is 60 degrees, okay? All right. So the reference angle happens to be 60 degrees for the 240 degree angle, okay? All right. Now let's figure out, using our reference angles and our angles, the value of sine of negative 210, tangent of 135, and cosine of 240. First thing you do when you get a sine of especially a crazy looking angle like this is you figure out what is the sine of the reference angle, because the sine of the reference angle is related to the sine of the original angle. So I know that the sine of negative 210 is equal to the sine of 30 degrees in some way. What is the sine of 30 degrees? I'm going to go look up at my table here. The sine of 30 degrees is 0.5. Okay, so I'm going to put sine of 30 degrees is 0.5. Now the question is, what is the sine of negative 210 degrees? Okay, so the way I'm going to look at that is I'm going to say, okay, sine, remember, is opposite over hypotenuse, right? So in this case, I'm looking at the sine of negative 210 degrees. It's this triangle here. The opposite would be this line here, and the hypotenuse would be this line here, right? Now, in this case, is the green length positive or negative? And the only thing that would make it negative would be if it's pointing down. In this case, the green length is pointing up, so that means the opposite is positive. Now, the blue line, the hypotenuse, it's diagonal. It points in all directions, but it's always positive, okay? So in this case, I know that the sine of this angle, negative 210 degrees, is positive because the opposite is positive, okay? So I would just take the same value that they gave me for the reference triangle, and I would use the exact same value with a positive because I know that in this case, the opposite is positive, okay? The sine is positive because the opposite side is positive, all right? All right, let's do tangent of 135 degrees, okay? So with tangent of 135 degrees, we know that it's going to be related to the tangent of the reference angle, tangent of 45 degrees. So if tangent of 45 degrees, let's see what that is. Tangent of 45 degrees is going to be, tangent of 45 degrees is 1. So we're going to put 1 here, okay? And if tangent of 45 degrees equals 1, that means the tangent of 135 degrees might be equal to 1 or something related to 1, okay? So let's take a look at the triangle. So if we're looking at tangent, remember TOA? So TOA says the tangent is actually opposite over adjacent. In this case, what is our opposite? Our opposite is this green line here because it is the line that's opposite from the middle angle. The adjacent is this red line here because it is next to the center angle, okay? So if I look at the red line and the green line, I can see which ones are pointing up and right and which ones are pointing left and down. If a line is pointing up or right, we consider that to be a positive number. If a line is pointing left or down, we consider that to be a negative number. So in this case, can you see that the opposite, which is the green line, is pointing up, so it's positive? And so the opposite is positive. And the red line is pointing left, so it's the adjacent, and it is negative, right, because it's pointing left. So the opposite is positive, adjacent is negative, positive divided by negative. If it's positive divided by negative, that is equal to negative, okay? So in this case, instead of tangent of 135 equals to 1, we're going to put tangent of 135 equals negative 1, okay? Because if the opposite over adjacent is a negative number, that means that the tangent of 135 degrees is going to be the negative version of the reference angle value, okay? So in the first case, do you see I did not modify the original sine value of the reference angle because my opposite was pointing up, so it's positive. In the second case, I did change my original value to positive 1. I changed it to negative 1. I changed it to negative 1 because the opposite divided by the adjacent was a positive number divided by a negative number, which gives me a negative number. Okay? Let's do the third one and the last one. So 240 degrees, the reference angle happens to be 60. So I know that cosine 240 is going to be related to cosine of 60 degrees. What is the cosine of 60 degrees? Let's check. Cosine of 60 degrees is 0.5. Okay, so I know that the cosine of 60 degrees is 0.5. The question is, what is the cosine of 240 degrees? Okay, so cosine of 240 degrees, that would be adjacent divided by hypotenuse. Let's look to see what is our adjacent here. Our adjacent here is the horizontal line that's next to the center angle. Okay, and what about the hypotenuse? The hypotenuse is this purple line that is going from the center of the circle to the red dot. Okay? So, how would I calculate cosine? I would calculate the blue length divided by the purple length because it is the adjacent divided by the hypotenuse. Okay? Now, if you look at the blue line and the purple line, the blue line extends from the center to the left. So that means it is a negative angle. So the adjacent is, or not a negative angle, it's a negative length. Okay? So the adjacent value is negative. What about the hypotenuse? The hypotenuse is kind of pointing down. No, the hypotenuse is always positive. Okay? So when you do adjacent divided by hypotenuse, you have a negative number because the adjacent is pointing left, and then the hypotenuse is always positive, so you just put positive on the bottom. So negative divided by positive gives you a negative number. So the cosine of 240 degrees is the negative version of the cosine of the reference angle 60 degrees. So the cosine of 240 degrees is going to be equal to negative 0.5. Okay? So that's how you do those. What you do to find the sine or cosine of a weird angle like bigger than 90 degrees or less than 0 degrees, like negative, you find out what the reference angle is. You take the sine, cosine, or tangent of the reference angle, and then you figure out, is it going to be that number or is it going to be a negative version of that number by checking the signs of adjacent, opposite, and to see if you end up with a positive or negative sine, cosine, or tangent value. Remember when you do that, the hypotenuse is always positive. Okay, that's it for this page.